these 3 meetings, we will discuss some issues. Today, at the beginning, very short introduction to descriptive statistics. Statistics which we use when we want to describe objects which are described by different variables. And today also I'm going to talk about cluster analysis. Cluster analysis, it is a method of analysis which we use when we want to analyze relationships between objects. Which objects are similar, which are not similar, and so on. So it is the main problem for cluster analysis. Next, during our next meeting, next week, we will be talking about correlation analysis and about regression. So these topics are connected with the problem of description of relationships between variables. And the last topic, which also I'm going to present next week, is related to verification of statistical hypotheses. So it is a short summary of our course. And today we will start with descriptive statistics in the first part, and in the second part we will be talking about cluster analysis. I will try to share my screen. This presentation, as I said before, is available for you some minutes ago, I made one change. I added this picture which you see here. So in this version, which was shared with you, you can't find this picture, but it is for very, very simple, and I will talk about it. So this presentation has a form of Jupyter notebook. And all pictures which are inside this presentation, you will find also in this file which was shared with you. There is a folder which is called graphics, and all these pictures are inside this folder. So we are going to talk about statistical data analysis, about some methods and some tools which will have a form of programs in Python, which we can use for analyzing relationships between objects, relationships between variables, and which we can use for description of objects. So this is my notebook, and here in the first cell, I attached some objects, some libraries, which I will use during today's presentation. Also, I'm going to use one dataset, iris dataset. I think that you met this dataset. It is, in my opinion, the most popular dataset which is used in statistics. It describes 150 flowers. All of them belong to iris flowers, but they are divided into 3 groups, 3 species, versicolor, setosa, and virginica. So we have 50 objects describing iris versicolor flowers, 50 objects describing iris setosa flower, and 50 objects describing iris virginica flowers. Together, we have 150 objects. every flower is described by 4 variables, 4 features. They are related to size of these 2 parts of every flower. These upper parts are called petals, and these lower parts are called sepal. And in this data set, we have 2 variables, 2 features describing petals, and 2 describing sepals. About sepals, we can find information about the length and about the width of sepals, of these lower parts. And similar information we have about petals, length and width. So here we have 4 variables. And we have also the 5th variable. Here on this picture, it is called class label. And in this variable, we have the information about species to which a given flower belongs to. So we have information here, and it has this form which we see here, setosa, versicolor, or virginica. So we have labels, we have names of species in this column. And it is the idea. So it is a very small data set, but also it is very useful for presenting some aspects related to data analysis. As I said before, I think that it is the most popular data set in statistics. So also during our course today, and maybe also during our next meeting, we will talk about it. It is a picture, but of course we need real data. I'm going to use this data describing these flowers, which are within sklearn library. SK, it means scikit-learn library, which it is the most popular package library for Python, which we can use for machine learning. And we have sub-package in it with some exemplary data sets, and we can use this data set in this form, which we see here. But here you can find a program which is useful for loading this data set, and I made some modifications here. I transformed it into typical data frame object, which are used in Python or in R language or in other languages. So this program is for preparation, this data frame. Of course, I executed it earlier, but you can also execute it, and you see the information that this object, which was created here, it is a data frame, and here we see some elements, first 5 lines, first 5 rows from this data set. So we see 4 columns corresponding to these variables, which I mentioned before: sepal length, sepal width, petal length, and petal width. And species, it is a name of this group of flowers which are described in some lines, in some rows of this, data frame. So of course we have 150 objects, 150 rows, lines in this data frame, and we will use this data set as a material for conducting our calculations. So it is this data set. And first issue, which I'm going to present today, is related to descriptive statistics, which we use for describing objects from perspective of different features. These methods are used for describing values which we have in columns of this data frame. So we will describe values which we have in every column. To perform this calculations, we should run this describe function. Of course, there are also other packages, but I think that it is the simplest form of generating this information, this descriptive information about values of variables. So I used it here. So this instruction is for conducting calculations which are necessary for finding these values which we have here. I printed these values here, and our statistics for every variable, here I use only numerical variables, we can see here. So now some words about them. Some of them are very, very simple. Count. Count, it means the number of values. So in every column we have 150 values. Mean. It is an arithmetic mean calculated for every column. So for the first column, for the variable sepal length, it is 5.84. Mean value. To calculate mean value, we know we should sum up all values and next divided them by a number of observations. It means by 150. Standard deviation. Standard deviation, it is very important information. We will talk also about it during our class on mathematics, but here also we use this value, standard deviation. How to interpret it and how to calculate it. Here I have a very, very simple example. We have a variable in this first column, and we have values for 20 objects. These values which we have in this first column. During first step of calculations, we calculated average value for this column. So I sum it up, and after it divided by the number of observations, so by 20. And the result is here. This result was repeated in every line. So it is a mean value for the first column. After it, I calculated the difference between a given value and mean value for every row. You see here, these values are in the third column. Some of them are positive, some of them are negative, and it is very interesting. It was not, their values were not summed up here, but the sum of all values is equal to 0. You can check it. So these differences we have here. Here you have these differences squared. So I calculated the second power of these values which we have in the third column. All of them, of course, are positive. I performed this operation because I wanted to transform all values which I had in the third column to positive values. Therefore, I squared them. Of course, it is the main popular way in which we can transform numbers to corresponding positive values. But there are some other possibilities. For example, we can calculate absolute value for every element, and also the results are always non-negative. They are positive or are equal to 0. So here in the fourth column, we have these differences squared. And I summed them up. The sum of them is here. And after it, I divided it by the number of observations, by 20. So we can say that it is a mean squared difference between a given value and a mean value calculated for all observations. It is a measure of dispersion. This value is called variance. So it is a variance. It is a variance which is calculated in this way and which we can use for measurement of dispersion, dispersion around the mean. And sometimes we can say that it is a measurement of variability for a given variable. It is a variance. And the square root of a variance value is called a standard deviation. Standard deviation can be interpreted as an average distance between given value and the mean value calculated for all values of this variable. So it is an average distance between the first and the second column. It is a standard deviation. And this information about standard deviation we can find here in this row, in this line. So we see that these values are different for our variables. Very often, variance or standard deviation value is used as a measure of the amount of information which we have in a given variable. So it is the information amount in a variable. So we can say that when we are talking about our variables, our 4 variables, so for us, the most important variable is petal length, because standard deviation is the highest. So we can say that, that this variable, petal length, carries huge amount of information. When standard deviation is equal to 0, it means that all values in a given column are the same. And in this case, this variable does not carry any information about our objects. We can say that it does not carry any information because it is not useful, this variable is not useful when we want to divide objects into groups of similar objects, into clusters. So if standard deviation is higher, then we can say that a given variable carries more information about our objects which we are going to analyze. So it is a standard deviation. Next, we have minimum value for every variable and maximum value. It is the last row. So the interpretation for these measures are obvious. It is the smallest and the biggest value in a given column. Here, we have very interesting information, which are here labeled as 25%, 50%, and 75%. These values are called percentiles. It is a 25th percentile, 50th percentile, and 75th percentile. How to calculate them and how to interpret them. How we can interpret these values. Percentiles belong to a group of measures which are called quantiles. We have many types of quantiles. It is a general term, a general concept, but its interpretation is very easy. When we have a given variable, numerical variable, we should order all these values. For example, we have a given variable, sepal length. We can analyze all values which we have in this column, and we can sort them from the smallest to the biggest. So the first operation which I should perform, it is performing a sorting operation. I have to sort all these values from the smallest to the highest, to the biggest. And next, I should divide this list of values, this list of sorted values, into some parts. And it is very, very important to have the same number of elements in every part. For example, I can divide this list of sorted values into 4 parts, 4 equal parts, equal when I'm thinking about the number of elements. So if I have 150 objects, I should divide this list into 2 halves. So I have 75 here and 75 here. And every half, I should divide it into 2 equal parts. In every part, I should have 37 or 38 elements. So after division these values into this equal group, I should check values which I have on these borders between these groups. And generally speaking, these values which I have here are called quantiles. If I decide to divide my list of values into 4 equal parts, then I can talk about quartiles. And this value is called the first quartile. This value, which is in the middle, on the middle position in this sorted list, it is a second quartile or median. And this value, which we have here on this position, it is the third quartile. Also, it is possible to divide this list of values into 100 equal parts. And then values which we have between two consecutive parts are called percentiles. So when we are talking about the 50th percentile, I'm talking about a value which I have between this part to which I assign a number 50 and the next one, so it is 51st part. Of course, I have these, I can check these values here, these percentiles, or also it is possible to calculate them. So for the first column, I here calculated 25th percentile, here the 50th and 75th percentile. And I printed these values here. So I have a function which can be useful for calculating these values. But when I want to perform these calculations manually, I should remember about one problem which may appear. When the number of elements in our sequence, for example, we are going to calculate a median value. When a number of elements in our sequence is odd, then median value is equal to this value which we have in the middle of this list. When a number of elements in our sequence is even, then when we want to calculate a median, we should take these two values, which are very close to a middle position, because middle position is between them. And to average an arithmetic mean for these two values, and this value we should treat as a median value. How we can manually calculate percentiles, quartiles? We can, as I said before, we can sort values. So here in this vector V, in the sequence V, I have elements from sepal length column from our data set. I sorted them. And because the number of elements here is even, to calculate the median value, I took these two values, which are on the position 74 and 75, because we should remember that in Python, values are identified by values indices from 0, not from 1. And we can calculate here the median value. So we see that it is 5.8. So it is the same value which was calculated here. But we calculated it manually. So we see how we can perform these calculations, but of course there is no sense to calculate percentiles in this way, because we have a function which we can use. This function has two parameters. The first, it is a data set in which we have values, and the second, it is the information about the percentile which we are going to calculate. So here it is the 75th percentile. Therefore, I put 75 here as a second parameter. So these functions are very, very useful for describing these quantiles, in this case, percentiles. So it is, so these measures were calculated here. So we see that these very, very simple statistics are used for description of every variable which we have in our data set. Of course, also during our next meeting, when we will be talking about correlation and about regression, I will try to perform also some other statistics which we can use for describing relationships between variables. Also, I'm sure that you talked about it during classes on graphical presentation, because there are some forms of graphs which are useful in this case. So after this very simple remarks about descriptive statistics, I'm going to move to, I think, our main topic for today, cluster analysis. So, as I said before, cluster analysis, it is a set of methods which we can use when we are going to analyze and describe relationships between objects. In our data set, because I will use this data set, this iris data set for some further calculations in examples which I'm going to show you. In our data set, we have 150 objects. 150 flowers were described in this data set, and we are going to analyze relationships between them. Which flowers are similar, which are not similar. So we are going to answer the question if it is a homogeneous group, or maybe it is possible to identify groups of similar objects. So it is the main goal of cluster analysis. Analysis of the structure of our data set to answer the question if it forms one group of similar objects, or if it is possible to divide these objects into some groups which are called clusters, and to create these clusters. And in every cluster, we should have similar objects to describe this structure, maybe assign labels to every structure, maybe calculate some statistics for every cluster. So it is these topics, these issues will be the most important for us. How to study the structure of a data set from the point of view of objects, because we are talking now about relationships between objects, not about variables. Every object is represented by one row in our data set, in our data frame, because we use data frames here for representing our objects. So it is the main goal of our analysis. We want to analyze the structure of our data set. And to find clusters, it means groups of similar objects. How to do it? Of course, it depends on methods which we are going to use. But some steps are common for all approaches, all methods which we can use in cluster analysis. First, of course, we should define goals for our calculations, for our analysis. The general goal is always the same. It is to analyze the structure of our dataset. But sometimes we can add some details defining this goal. After it, we should prepare our dataset. In this example, we prepared this dataset in our on the first part of our presentation. I prepared this iris dataset. So I have this dataset in electronic form. Here in this example, in the form of data frame in Python language. And we will go process this dataset. Sometimes we should perform some initial operations, which are preprocessing, which are called preprocessing stage, preprocessing operations. They are related, for example, to normalization, to scaling our data. So all these operations sometimes are necessary. Of course, it depends on us. It is our decision, which if we want to perform these operations, for example, standardization or normalization or not. Next, we should calculate distance matrix. We should calculate distances between every pair, every two objects, every pair of objects. Of course, we can use different types of measures for expressing distances. Having this distance matrix, we can perform clustering stage. So we then can use a method which will allow us to identify clusters. Today, I will talk about 5 or 6 methods, and I will show you how to use them in practice for our dataset. And sometimes, not always, but sometimes, we should make a very important decision about the selection of a proper number of clusters which we have in our dataset. First, I'm going to talk about hierarchical methods. They are, in my opinion, the most popular in cluster analysis. And they allow us to build a hierarchy. Therefore, they are called hierarchical methods, hierarchical methods. They produce the result which has a form of a tree, hierarchy. This tree represents hierarchy of objects. Here we see a general view. We can see that I found this picture on Wikipedia. Here it is a picture which was generated in a program. In this case, it was Statistical program. But we will produce very similar, very similar pictures, trees using Python language. This tree showing the results of cluster analysis is called dendrogram. We have here a lot of people from Greece, so you can check if dendron in Greek language means tree or not, because I'm sorry, but I don't know Greek language. So it is a form in which results of cluster analysis are presented. It is a dendrogram. This picture shows relationships between objects. We have objects here. In this case, in this example, I had 10 objects, C1 to C10. So I had 10 objects. And first, we can think about all of them as about separate clusters. So at the beginning of this process, the number of clusters is equal to the number of objects. Every object forms separate cluster. And next, using distance matrix, we should try to find two objects which are very similar to each other. So we should identify these two objects for which the distance is the smallest. And in this case, I think that these two objects are very similar. Object number 7 and number 9. And these two objects, because the distance between them was very, very small, they were merged into one cluster. They were combined. They created here the first cluster. Distance between them in the moment in which this cluster was created is here. It is about 25. This distance is represented by this horizontal line, which we have here. Using the level on which we have this line, we can check the distance between these two objects in the moment in which they were merged. And after this merging operation, after creation of this first cluster, we had 9 groups. 8 groups with one object, and this 9th cluster, 9th group with 2 objects. And we repeated our process. We built a distance matrix between these 9 clusters, and to find 2 objects for which the distance between them was the smallest. And in this case, this smallest distance was for this pair of objects, object number 4 and 5, and they were joined. And we obtained, as the result, 8 clusters. We repeated this procedure, and we found that this cluster with 2 objects and cluster with 1 object, C1, they are very, very similar. Similarity is the highest for these two clusters. So we joined them. In the next step, we joined these 2 objects, but in the moment of merging these 2 objects, distance between them was about, I think, 180 units. After it, we added this object to this cluster, and we created this common group, this common cluster. After it, we added this object to this cluster. Next, we added this object to this cluster, and finally, we merge these 2 clusters into one group. So it is a dendrogram. And in this way, we can describe this dendrogram. The dendrogram presents the whole process of merging. At the starting point, we have groups, and the number of groups, a number of clusters is equal to the number of objects. And finally, at the end, we have only one cluster. But we must decide about the final number of clusters which we recognize in our dataset. We can make this decision looking at this dendrogram. we should compare levels on which clusters were created. The first cluster was created on this level, next on this, next here, after it here, next cluster was created on this level, and next here on this level. Next here, and the last cluster was created here. So we should check all these values, and we should find two values, consecutive values, for which the difference is the biggest. So we should compare differences between consecutive levels and to find the biggest difference. And the biggest difference is here, between this merging operation and this merging operation. The difference in levels for these two consecutive horizontal line here is the biggest. And in this way, we found a level on which we should cut this dendrogram. So we should cut this dendrogram using horizontal line between this and this level, because the difference between them is the biggest. So we should cut it, for example, on this level, equal to 400. And this horizontal line will intersect four vertical lines. This one, this one, this one, and this one. And these intersection points will define clusters which we obtained. The first cluster is composed only with this one object. The second cluster is composed of these four objects. The third cluster is here, and there is only one object inside this cluster. And the last cluster is here, and we have four objects in this cluster. So it is a very popular method for analyzing dendrograms. I will show you in some minutes how to prepare a program for cutting this dendrogram. So it is the idea of hierarchical methods. So the main feature of these methods is an ability for building a dendrogram. A dendrogram which presents the whole process of cluster creation, cluster forming. So we start, of course, our calculation with preparing the data. In our case, we have a data frame, but generally speaking, we should have a structure which has a rectangle shape with some objects corresponding to rows and features, variables, properties, which are represented by columns. So we have, in our case, in every row, the description of one object, of one flower, and in every column, we will have one variable. We will use for calculation numerical variables, so we will use 4 columns. And as I mentioned earlier, I can perform some initial operations. For example, standardization. Here we see the formula which I can use for standardization. So it means that for every column, I should calculate an average value, arithmetic mean, and standard deviation, and I should replace every value with a value which is calculated here. It is a standardization operation. A formula is here, but we should remember about the way in which we should interpret this formula. It is a formula which we can use when we want to have the significance of every variable on the same level. Because this transformation causes that mean value for values which we have in a given column after this transformation, for values which we have in a given column after this transformation, we can always calculate mean value, and it is always equal to 0, and standard deviation, and it is always equal to 1. So this transformation causes that values in a given variable will be changed, will be scaled in this way that mean value for these scaled numbers, scaled values which you have in a given column are equal to 0, and standard deviation is equal to 1. So it means that dispersion, variability of for every variable is the same. And we know that dispersion variability measured by standard deviation or variance, we can use as a measure of the amount of information which we have in a given variable. So after using this transformation method, the amount of information which is carried by every variable is the same. And it is the main goal for which we can use these methods of scaling. So scaling causes, from technical point of view, that every variable has the same variability. But when we are talking about information amount in which is connected to every variable, it causes that this information significance of every variable is the same. So then, after performing this standardization calculations, this transformation, after using this method of transformation, we can say that every variable will have the same impact on the final results. And it is, I think, the main conclusion which can be formulated here. If we want to cause that if we know that every variable should have the same impact on the final results, then we should use this method for data scaling, data normalization, data standardization. Of course, alternative approach is to use our variables in original form. It depends on us. It is our decision. But we should take into account all aspects of this decision, and we should select the best solution. But of course, this transformation has no impact on the number of rows and number of columns which we have here in our dataset. Next, we should calculate distances between objects. Objects which here are represented by rows in our dataset. We can use different types of distances. I think that there are many hundreds of definitions of different distances. Of course, Euclidean distance is the most popular. Here we see a formula for calculating Euclidean distance between two objects. It means between two rows from this dataset, between two vectors which we have in two rows in our data frame. So because this formula which is here, it is a distance which is calculated between two vectors. Two vectors which we have in two rows on our data frame, in our example, in our data table. How to calculate Euclidean distance? We should compare corresponding coordinates. We should calculate the difference between them. And after it, we should square this distances for every coordinates, sum them up, and at the end, we should take a square root. The interpretation for this formula is here. We know that rows, objects, can be represented by points in the space. To say true, as are represented by vectors, but these vectors are presented by points in the space, n-dimensional space, where n is equal to the number of columns, number of variables which we have in our dataset. So on this picture, we should assume that we have only two variables, two columns in our dataset. And in these columns, we can find coordinates for points. These 2 points represent objects. And when we are talking about Euclidean distance, then we should remember that Euclidean distance between 2 points is equal to the length of this line, which is connected to these 2 points. So having these 2 points, we can draw a line here. Here we see this blue arrow, but it is a blue line connecting to these 2 points, and the length of this blue line is equal to Euclidean distance. So the interpretation for this formula is very, very, very simple. And very often, this measure, Euclidean measure, is used for calculating distances between objects which are described by numerical variables. And also in our examples, also I will use it. This method for calculating distance. I will use Euclidean distance. So we know how we know main features of agglomerative approach. First, every object forms separate cluster, and we try during consecutive steps to join, to merge objects which are similar to each other. And finally, we have one cluster with all objects. Next, we should decide about the we should decide, we should select the final number of clusters and to cut this dendrogram using horizontal line. I'm going to talk about some methods which we can use to perform these calculations. But maybe we will take a short break, maybe 7 minutes. So we will start our second part of our meeting 10 past 1. 7, I would like to invite you for 7-minute break. Okay, I think that we can start our the second part of our meeting. And now I'm going to show you these methods of cluster analysis which are the most popular. First, I'm going to talk about some agglomerative methods. They are very similar to each other, but there is only one difference between them. This difference is related to a problem of selection of clusters which we will merge during the current stage of calculation. So here, please look at this picture once again. So, for example, here, we decided that we should join these two clusters, this one and this one. Here, on this step, we decided to merge these two clusters into one cluster. We chose these two clusters. And in different methods, different ways of selection of clusters for merging are used. To select two clusters which we are going to merge, which we are going to join, we should calculate similarity between them. And the first method, which I'm going to present, it is a method which is called single linkage method. Single linkage method, also you see here the name of this method in English and Polish and in Russian, but the idea is presented here. When we are thinking about merging two clusters, we should compare similarity between clusters, which is calculated in this way, which is presented here. So having two clusters, when we want to calculate the similarity between them, between these two clusters, we should find two objects, one belonging to the first cluster and one belonging to the second cluster, for which the distance between them is the smallest. And when we compare similarities between different pairs of clusters, we use this distance for representing this similarity. So it is the shortest line connecting objects belonging to these two clusters. And this method is used in single linkage method. The opposite approach is used in complete linkage method. When we have two clusters and when we want to calculate the similarity between them, we should find two objects for which the distance is the biggest. And this distance is used as a measure of similarity between clusters. Also, we have average linkage method. And in this approach, we should calculate distances between every pair of objects belonging to these two groups, to these two clusters. And these distances are represented by these lines, which we see on this picture. We should calculate the average value for these lengths, and this average value represents the similarity or the distance between these two clusters. And the last agglomerative method, which I'm going to present, it is a word method. This method was invented by Ward, so his name is here in the name of this method. The problem here is the same. How to select clusters which we should merge, which we should join. But the approach and the measure which is used here is different. In this approach, we use the information about the within cluster variance. Please look at this picture. We have 3 clusters here, and in every cluster we have objects. Objects here are represented by these red points. Red points represent objects. We have 3 clusters, and now we should choose 2 of them which should be merged during the next step of our analysis. There are 3 possibilities. We can choose and merge these 2 clusters, or these, or these. What is the criterion which we will use when we will be making this decision? It is related to variance. First, we should calculate a variance value for every cluster. It is within cluster variance. So a variance which is related to objects which are in the same cluster. How to calculate it? For every cluster, we should identify a point which is in the center of this cluster. These points, which are called centroids, are represented here by these gray objects. And in every cluster, we should calculate distances between every object, it means red point, and its centroid, this point which is in the middle of this cluster. So here we have these distances here and here. And using the information about the lengths of these black lines, we should calculate the variance. And of course, we can calculate the average variance for these 3 clusters. After these calculations, we should consider what will happen if we join these 2 clusters. After joining these 2 clusters in one cluster, then the centroid of this new cluster will be here. It is represented by this green point. And distances between this centroid and points which we have in this cluster are represented by these green lines. If we decide to join these 2 clusters, the centroid will be here, and these pink lines represent distances. Also, it is possible to calculate variance in this case. And the third possibility, we can join these 2 clusters. Then the point which we have in the middle of this data set is here, this blue one. And these blue lines represent distances. So we have 3 possibilities. In every possibility, we see that within cluster variance will increase, because we see we can think about this variance as about average length of these lines. So always it will increase. Always we will have bigger value for this variance. But we should select this possibility, this solution, for which the increase of variance will be the smallest. And these two clusters we should join during next step. It is the main assumption and the main criterion which is used in this method. All these methods which I presented here can be used for producing dendrograms. And we know that finally we will make a decision about the level on which we should cut this dendrogram. Okay, now I think that we can move to our practical part. I talked about different methods, 4 methods, and here I will use 2 of them for performing calculations using our dataset. First, single linkage method. The first method which I presented here, this method, in which the decision about selection of clusters for merging is based on the shortest distance between objects belonging to 2 clusters. For all these methods, when we want to use them, we use the same function, linkage. Linkage function, this function is here, and it has 2 obligatory parameters. The first parameter is here. It is a definition of data. Our object with data, it is a data frame, and this data frame is called df. You remember this data frame. It was created in the first part of our meeting, and we have the description of 150 flowers, irises in this data frame. We have some columns, and here I selected only these 4 columns, because I know that in these columns we have numerical values, and these 4 numerical variables I used for further calculations. And I want to use single linkage method, therefore I use this parameter single. Of course, also we can define a measure which I used for calculating distances. I used here the default way for calculating distances. It is a Euclidean method. This method is used here. We see here the definition of this function, so if you like, you can change it. But I think that when we are talking about numerical variables describing objects, Euclidean's distance is very, very good. So these parameters define the way in which cluster analysis will be performed. And the results of classification will be assigned to this object. Here I created a dendrogram, and this command, dendrogram, is for drawing this dendrogram. So the results we see here. 150 objects. I know that these identifiers are small because we have 150 objects, and the dendrogram. The dendrogram, I think, suggests that there are two clusters, but we know that it is not true. So the results are not correct here. This method was not able to identify the real structure of this dataset. Because we know in our dataset, we have 150 objects belonging to 3 types of irises, 3 species of irises. And every species is represented by 50 flowers. So here, I think, one type of irises was recognized properly. But here, I'm not sure that the results are correct. I know that they are not correct, but we will check it. In this situation, we have the information about the real way of assignment of objects to groups. Because in our data set, in our data frame, we have a column species in which we have the information about the group to which a given flower should be attached, should be assigned. So the situation is very good. And therefore, it is possible to evaluate the quality of our classification. So we see that without using any measures, in some seconds, we will try to use to calculate some measures which represents the quality. But after observing this dendrogram, we see that there is something wrong with these results. So now I want to cut this dendrogram into parts. And it is possible by using this function, fcluster. Fcluster function is used for cutting this dendrogram using horizontal line. We should define a position of this line. And here I defined this position here. It is not a value which we have here, but this parameter says how many clusters I'm going to obtain. Here I'm going to obtain 2 clusters. So the program will select the distance on which this line will be located in this way, for which we will get 2 clusters. So for example, here. So, and this criterion parameter says that I'm going to make this decision in this way. So taking into account the number of clusters which I'm going to obtain. And the results of clustering I will assign to this new column which I created for my dataset, in my data frame. I added a column cluster single 2 groups. It means the results of cluster analysis using single linkage method, and after division into 2 groups. And the results we see here. We have values 1 or 2 in this column. these values, 1 or 2, represents clusters to which objects were assigned. Of course, it is not possible to assign names to these groups because cluster analysis, methods of cluster analysis, do not deliver names for clusters. They only deliver the identifier. And in this case, this identifier has a form of an integer value. So we have a first cluster and the second cluster. The next line here says that I'm going to cut this dendrogram at the level at which I will obtain 3 clusters. So it is here. 1, 2, 3. So I will obtain this cluster, about 50, I think, objects. The second cluster is here with only 2 objects, and the rest of objects are in the third cluster. So we know, comparing these results with the with the information about the proper assignment of objects to clusters, that the results are not correct. So here I added the information about the clusters which I obtained into my data frame. And I want to compare these informations which I obtained here with the information about the proper way of assignment of objects to clusters, which we have in the column species here. I'm going to compare the results of classification, of real classification, which we have in species column, with the results which I have in these 2 columns, cluster single 2 groups, cluster single 3 groups. And I am going to say, if I obtain the same division, the same way of division objects into groups, or no. We see that it is not the same. But how to express using numerical values? The most popular measure which we can use for comparison classifications, 2 different classifications, is the RAND index. RAND measure, RAND index, it is the most popular measure which we used. There are some different forms of the RAND index. Here I prepared a description of this measure, and it is related to the basic form of this RAND index. In Python, we use some small changes, and therefore the implementation which we have in Python is called adjusted RAND index. But the idea is completely the same. In adjusted version, we use only a scaling value which can improve the quality of this index. Please look at this picture. We have 5 objects from A to E. And we are going to consider 2 ways of classification of these 5 objects. The first is here. I divided these objects into 2 groups. In the first group, I have A, D, and C. And in the second group, B and E. In the second classification, also, I have two clusters. And in the first cluster, I have A and D object. In the second cluster, I have C, B, and E. When I want to calculate rand index, I should create this table. And in this table, the number of rows and number of columns is equal to the number of objects. And I filled up only this upper part of this table, of this square matrix. I put here symbols A, B, C, or D. And I put letter A if objects represented by a given row and a given column are in the first classification in the same cluster and also in the second classification in the same cluster. So for example, A we have here between A and D. A and D here in the first classification. These two objects are in the same cluster, and also in the second classification, they are in the same cluster. I put letter B here if two objects are different in the first classification, in different clusters in the first classification, and if they are in a different cluster in the second classification. B, I have here, between A and B. A and B. We see these objects here. They are in two different clusters. And here in the second classification, also they are in two different clusters. Letter C represents the situation in which two objects are in the same cluster in the first classification and in two different clusters in the second classification. C is here, between A and C. AC. Here, these two objects are in the same cluster. Here, they are in two different clusters. And the last possibility, letter D. Letter D means that two objects are in two different clusters in the first classification, and they are in the same cluster in the second classification. D is here, between B and C. B and C. Here, these two objects are in two different clusters, and here in the same cluster. Having this matrix, we should calculate a value which is defined here, and this value is equal to the rand index. It is this hash symbol means number of occurrences. How many times letter A is here, plus how many times letter B we can find here, divided by the number of occurrences for A, B, C, and D. So for these two classifications, which we have here, we have index, rand index equal to 0.6. The maximum value is 1. We have 1 when we have the same two classifications. So it is the first possibility of comparison. And here I used this function for calculating this rand index. I should put names of two columns from which I'm going to take information which are used during comparison. So I compared values which I have in column species. It is a real way of classification. And here cluster single free groups. So the results of clustering which were obtained using single linkage method for free groups. And rand index is here, 0.56. It is rather small. So we see that the results here are not good. Also, when we want to compare the results of classifications, we can create the contingency table. This contingency table is created here. I want to compare values from species and cluster single free groups, columns. And we have this contingency table here. Here we have groups, clusters, which are defined in species column, Setosa, versicolor, virginica. Here we have clusters which we have in cluster single free groups column. These clusters which I obtained during this classification problem, which I obtained trying to solve this classification problem. And we see the way in which objects belonging to these two real groups were classified. And we see that all Setosa flowers were assigned to the first group. Of course, it is not possible for this method to assign the name for this group, because our algorithm does not know the name of these flowers. It does not know that these flowers belong to Setosa group. It is the first cluster, but it was recognized properly because there are no objects from Setosa group in these two other clusters. Versicolor, all objects were assigned to the third group. So also we can say that it is correct. But the problem is here with virginica. Objects belonging to this cluster were assigned to the same cluster in which we have versicolor flowers. Only two objects were assigned to this second cluster. So we see that it is not proper classification. But I'm going to underline once again that it is possible to calculate these measures because we have in our data set the information about the real species. In a real situation, when we analyze, for example, companies, countries, cities, and when we try to form clusters, we have no information about the proper way in which these objects should be divided. So then it is not possible to use these elements, these measures, to evaluate, to express the quality of classification. Here we can check the quality of classification using the same method, single linkage method, but after cutting the dendrogram into two groups. And here I compare real classification from species column with obtained classification. Contingency tables here. So we see Setosa was recognized properly, versicolor and virginica, all flowers were assigned to one group. So we see that these flowers must be similar to each other. Rand index also is very low, 0.56. We can try another method. For example, word method. In this case, we use the same function, linkage. We should only change the second parameter. Word, it is the name of this method which I can use. Also, Euclidean distance is used here. So the results are here. Also, we see that here we have one cluster, and here this part we can interpret as the second cluster, but also it is possible, I think, to interpret these objects as objects belonging to two clusters, because we see that it is possible to draw this horizontal line here and to create three clusters. But as in our previous example, I divided this dendrogram into 2 and 3 clusters. And I saved the information about the way of clustering into columns: cluster word 2 groups, cluster word 3 groups. So now our data frame looks like this object which we have here. Cluster word 2 groups, cluster word 3 groups. And comparison. Comparison is here. Contingency table. And Setosa, as in the previous example, was classified properly. Versicolor is here. So 49 objects to cluster 3 and 1 object to cluster 2. Virginica, here also we see this problem. 35 was classified here to the second cluster, so we can say that they were classified correctly, and 15 to this cluster, and they are not classified correctly, because I think that this third cluster should be used for versicolor objects. Rand index is 0.73. So it is higher than for the previous example. When we use 2 groups produced by Ward's method, the results are here. We see Rand index is here, 0.56, very similar to single linkage method. So rather poor classification. So we can conclude that it is possible to use agglomerative methods, but for this case, for this example, in which we use iris dataset, it is not rather possible to obtain proper classification. This dataset is small because we have only 150 objects. But this dataset is very difficult for analysis. It has rather complex structure. Therefore, we see that it is not easy to classify these objects properly. So we discussed methods which we can use when we want to obtain a dendrogram. But of course, there are some other types of methods. It is not possible to discuss all of them during our meetings, but I'm going to present today k-means method. It is a method which we use when we want to divide objects into defined number of clusters. For example, we have objects and we want to divide them into 3 clusters. And this method can be used for solving this problem. It is not possible to create a dendrogram, a hierarchy of objects, because here the results has completely different form. It is a division of objects into defined number of clusters. How this method works? The explanation is here. We have some objects, 7 objects in this example, these points which we have. And first, randomly, and in this case, I'm going to divide them into 2 clusters. So at the beginning, I must define the number of clusters which I'm going to obtain, 2 clusters. And first, they were assigned randomly into these 2 clusters. So one group is represented by yellow points, the second group by blue points. The assignment was made here randomly. So this and this object, these objects were assigned into yellow, these objects into blue group clusters. And next, we should iterate through all objects. And for every object, we should check if a given object was classified properly or not. How to check the correctness of classification, of assignment? First, we should calculate centroids for every cluster. Centroid is a point which is in the middle of a given data set. So for yellow objects, the center point is here. For blue objects, it is here. These centroids are represented by these stars, yellow star, and blue star. And during this iteration, for every object, we check the distance between a given object and the centroid, which has the same color, for example, to this yellow centroid, and to other centroids, to this blue one. And the distance to the centroid, which has the same color, should be the smallest. So for this object, it is true. But for this, it is not true, because the distance to blue centroid is bigger than distance to a yellow centroid, to the yellow centroid. So these objects which were assigned in improper way are marked here using these red circles. And for these objects marked here, we should change the way in which they were assigned. And now we have this situation. For this situation, we should calculate centroids, new centroids, And after it, again, we should check the correctness of assignment for every object. Now, it will be okay for every object. Every object now is correctly assigned. So it is the final result. So it is the idea of k-means algorithm. K, because we have k clusters, means because the information about the centroids, points for which coordinates are calculated using mean function are used. How to implement it? Also, we have a function, k-means. This function here in green, we see it. It is a function for creating an object, Python object, in which we will have all data for performing this calculation. So I defined here the number of clusters which I'm going to obtain, and it is a number of repetition. Here 10. It means that this process will be repeated 10 times, and the best result will be sent to the user as the final result. For performing these calculations, I use this fit method of this, which I have in this object. And the result means the information about the assignment of objects into classes are here. And we see here, and we see the comparison of the results obtained here with the real classification. Rand index is on this level, 0.73. So results are similar, the quality of results is similar to these which we obtain using words method. So it was a short introduction to cluster analysis. I wanted to show you how these methods works and how to use them. And during our next meeting, we will be talking about analysis of relationships between variables. Thank you very much.
Thank you for the presentation.
Thank you very much. And see you soon.